Hi there, Geometry. This is Mr. Monahan here for the Chapter 5 practice test. Looking at each of these problems, feel free to skip ahead with whatever ones you need to get help on. Don't be afraid to ask your teacher for more help. I'll be doing my answers over here on this iPad screen, so just feel free to skip to whatever you need to see. Question 1 says find the value of x. The diagram is not drawn to scale. So what we have there is a triangle with a mid-segment of 14. So what we need to do is understand that the mid-segment is half the length of that third side, and it's parallel. So what I need to do is I need to take that 14 and I need to double it. 2 times 14 is 28. That's what x has to be. So with mid-segments, you're either going to be cutting something in half or doubling it, depending on if you're going from the mid-segment out or if you're going from the third side in. So from 14 to x, I would have to double, multiply by 2. So that's number 1. Number 2 is another mid-segment problem. So with that one, again, we have this 2x plus 10 in here that's in the middle. We have a 5x plus 5 on the bottom. What we want to do, a lot of people will just try to set those equal. 2x plus 10 equals 5x plus 5. The problem is those are not equal to each other. The truth is that this 2x plus 10 is only 1/2 the length of the third side. So what I'd always say is take the thing in the middle, the 2x plus 10, and double that right away. If you double that 2x plus 10, now it's equal to the 4x plus 5. Or 5x plus 5, I'm sorry. So make sure you use distributive property. So we have 4x plus 20 equal to 5x plus 5. When I subtract both sides by 4x and subtract both sides by 5, I have x on the right, 15 on the left, so x has to be 15. That's blank number 1. The length of the mid-segment, which is the second question they ask, is putting the 15 into this equation, the 2x plus 10. So what we have then is 2 times 15 plus 10, or 30 plus 10, which is 40. So the length of the mid-segment is 40. Okay. What should be true is that that bottom side should be 80 then. So you can check that if you plug 15 in here. 5 times 15 is 75, and then 75 plus 5 is 80. So we also know that that one, we know that we checked our answer. All right, number 3. What we have here is an angle bisector. So if you see these angles marked as congruent, this ray, A towards D, is an angle bisector. What that means is that this piece, the 7x plus 4, has to equal this piece, the 5x plus 6. Since D is on the angle bisector, it's equidistant from the sides of the angle. So what I know is that BD has to equal CD, and then I can start to plug those in. So 7x plus 4 is BD. That has to equal CD, which is 5x plus 6. Subtract both sides by 5x. Subtract both sides by 4. I end up with 2x on the left, positive 2 on the right, or x is 1. Then they want you to plug in for BD. If x is 1, then we plug 1 in for x. 7 times 1 is 7, plus 4 is 11. So BD is 11. Check your work with the other one over here. 5 times 1 is 5, plus 6 is also 11. So these are both 11. Moving on. Number 4, which angle has the biggest measure? So this is called an exterior angle. These two, B and C, are called remote interior angles. What that means for us is we could write that angle A is equal to angle B plus angle C. What that means, here's what we know. Angle A is a positive number. Angle B and angle C are both positive numbers. So they're not 0 and they're not negative. So we had something called the comparison property. If we have one positive thing that's equal to two positive things added together, this has to be the biggest angle of all three, or it works with sides too. But angle A is the biggest, and then you don't have to write this because it's multiple choice, but by comparison property. I'm just going to write by comparison. So since angle A is the angle that's all by itself, B and C are added together to make A, I know B has to be smaller than A, and I know C has to be smaller than A. Okay, number 5, what is the smallest angle in the triangle? So small angles are always across from small sides. So what that means here, the smallest side is 3. So across from that smallest side is the angle that's the smallest, which is B. So for this one, there's not much work to show. B is the smallest, and then C is the next smallest. A is the biggest because it's across from the 7. So this one is just B. This one lists the angles of the triangle in order from least to greatest. Okay, well, let's start with the smallest side. So 10 down here is the smallest side. That's across from X, so angle X has to be the smallest angle. The next smallest side is this 11. Across from that is angle Y. So angle Y has to be next, which means angle Z has to be last. So 13 is the biggest, which is across from Z. So X, Y, Z for this one, option B for me. Okay. List the sides in order from least to greatest. This isn't too different. It says the diagram is not drawn to scale. So first thing we should do, I'm just going to copy this one down. Here's Z, X, and Y. Before we can really start, we need to understand what this last angle is, this angle Y over here. We need to put a number in for that. So we know that there's 180 degrees in the triangle. So 58 plus 78 plus angle Y, they have to equal 180. So if you do 58 and 78 together, that's 136. And if you subtract those, or subtract that 136 from both sides, it looks like we get 44. So I'm going to put a 44 right in here. And now I know that 44 is the smallest angle of the three. So across from the 44, this is the shortest. So I'm going to put 1 right here. The next smallest is 58. I'm going to put a 2 right here. The next smallest is 78. I'm going to put a 3 right here. So in order, side number 1 is XZ. Side number 2 is ZY. Side number 3 is XY. So we just have to find which answer that goes with. So XZ first. So it's either C or D down here. Then X or YZ next. So it's got to be option D on my screen. They might be jumbled up for you. I don't remember if I had those jumble up every time. Okay. But the smaller angles make the smaller sides. The bigger angles make the bigger sides. Okay, question number 8. Which of the following could not be 3 sides of a triangle? 3 side lengths of a triangle. So what we know about these is any 2 sides have to add up to be bigger than the third side. So number 1, or letter A, I should say, 5, 12, and 13. We know that this is a triangle because 5 plus 12 is bigger than 13, because 17 is bigger than 13. 5 plus 13 is bigger than 12. 18 is bigger than 12. And we know that whichever one I missed, 12 plus 13 is bigger than 5 because 25 is bigger than 5. So for example, this one could be a triangle. Okay, I'm going to skip ahead to the one that cannot be a triangle. It's this 5, 5, 10. And here's why. If you do 5 plus 5, that has to be bigger than 10, but 5 plus 5 is 10. And 10 is not bigger than 10. 10 equals 10. So this is not true. So this one cannot be a triangle. So our answer is 5, 5, 10. If you were to check the other ones, B and C, you would have seen that they both also worked. Okay. So a similar question here, number 9. The two sides of a triangle have lengths 4 and 10. Okay. Complete the inequality to show the possible lengths of the third side x. So the possible lengths of this third side is what they're looking for. So in other words, we know that the three lengths of this triangle are 4, 10, and x. So we're going to do kind of what we had just done. I know that 4 plus 10 has to be bigger than x. In other words, 14 has to be bigger than x. That's going to be important. What that means is that x has to be less than 14. These two mean the same thing. So what that means is if x was 14, this could not be a triangle. 13.9 would be okay, but 14 cannot. The other two equations that we know have to be true would be 4 plus x has to be greater than 10, and 10 plus x has to be greater than 4. If you subtract both sides by 4 in the middle one, you get x has to be greater than 6. If you subtract both sides by 10 over here, it's x greater than negative 6. So one of those is redundant after knowing the first one. So if I know that x is bigger than 6, I know that it can't be 5, it can't be 2, it can't be 0, it can't be negative 1. So it obviously can't be negative 6 either. So that one's just kind of unnecessary. So what I know is that x has to be bigger than 6. It could be 6.1, but if x was 6, then I couldn't make a triangle with two other sides of 4 and 10. So here's how you write the range of values. Here's the final answer. It's something is less than x, which is less than something. We know that 14 is too big. We know that 6 is too small. So 6 has to be between, or x has to be between, 6 and 14. Okay, that's how something like number 9 works. Let's look ahead to number 10. This is from 5-7. It says if angle WXZ is 85. That's this one right here. Let me just draw a quick sketch. What we know here is if we put a 85 on this side, we know we have to have a 95 on this side because these two need to make 180 since it's a straight line. Then what we also know is that across from these 85s we have WZ and we have YZ. Okay, well, since 95 is bigger, that this one is longer. Since 85 is smaller, this length is shorter. Okay, so what we know is that WZ has to be smaller than, less than, YZ. And that's one of our options here. For me, it's option C. Okay, moving on to number 11. It says points B, D, and F are all midpoints of the sides of ACE. So that means we have a lot of mid-segments in this picture. We know that FB is 12. We know that AC is 30. They want us to find FD. FD is this one right here. They want us to know, or want us to tell them what FD has a length of. Well, FD has a length of half of this side, and they told us AC is 30. So since AC is 30, we got to divide that by 2. That's 15, which is going to be our FD. So 15 is FD. And that's all you got to do for that one. Remember, mid-segments, you should be thinking about multiplying or dividing by 2. Number 12 is right off of your Chapter 5 quiz. It says the length of DE is shown. What other length can you determine for this diagram? So not a lot of work to show for this one either. Here's the length of DE. They want to know what else is going to be exactly 12 units long. So what I see in the middle, GE, this is called a perpendicular bisector. Look at the 90 degrees in the middle. Look at the tick marks here. Any point on this line is equidistant from the endpoints of this segment that's getting cut in half at 90. So since E is on EG, this point E is the same distance away from D as it is from F. So if ED is 12, EF has to be 12, or FE has to be 12, which is option D. Number 13 is a matching one, really important. This is just vocab. Make sure it's on your note card as well, and you can have pictures on your note card. So you shouldn't get something like this wrong if you have a good note card. Here's what we have. Column A is the vocab term. Column B is the picture of that. So what you need to know is that circumcenter is where the perpendicular bisectors meet. That should be on your note card. So we're looking over here for a picture of perpendicular bisectors. It can't be B or C because there's no right angles anywhere in here. So it's either A or D. If you look at this one, up here, A, here's perpendicular, but also every side is getting cut into two equal pieces. So this picture here shows P as a circumcenter. So I would put A for that one. The incenter, that one is where the angle bisectors meet. So look for angle bisectors. So if you look at picture C, in the corners here, we have each angle is getting cut into two equal pieces. So this would be option C down here. The incenter is where the angle bisectors meet. The centroid is where the medians meet. So we're looking for medians. Remember that a median goes from a vertex to the opposite side's midpoint. That's what all three of these lines do in picture B. And then that leaves orthocenter has to be D. Orthocenter is where the altitudes meet, and an altitude goes from a vertex like A, perpendicular down to the opposite side. Doesn't have to be a midpoint, just has to be perpendicular to the third side. All right, finding the circumcenter. Okay, what you do for these is you draw the perpendicular bisectors. So you have to know what that word means. It means that's where the perpendicular bisectors meet. So what we have here is we have a triangle where what we want to do is find the perpendicular bisectors. So what we have here, I know this is kind of a quick picture, but this point is at 3 on the graph. This point is at 7 on the graph. Okay, so that's a distance of 4. So the midpoint would be here at 5, and what we would do is we would just draw a horizontal line through that. For the bottom, this is at 2 on the graph, and this is at 6 on the graph. Halfway between those two would be 4. So at 4, there would be a midpoint, and we would draw a vertical line. So these are both perpendicular bisectors. Okay, and what we have now is our circumcenter right there. And it's at the point 4, 5. That's all you got to do for something that says circumcenter. Number 15, find the length of WX given that ZX is a median of the triangle and WY is 42. All right, so they want this WX. We know the whole bottom is 42, and we know that this is a median. Medians go from a vertex to the opposite side's midpoint. So I know X is right in the middle of W and Y. So if WY is 42, we're just going to divide that in half. WX has to be 21. Since the whole thing is on the bottom is 42, half of that would be 21. Number 16, G is the centroid, and FG equals 9. Okay, find GC and FC. So I should probably just draw this one. I'll pause the video and just draw it, and then I'll talk about it. So give me 1 sec. All right, so I know that G is the centroid, and I know that FG, oh, here's G. I know that FG equals 9. Okay, they want GC, whoa. They want GC, and they want FC. Okay, remember that the centroid problems deal with short, medium, and long side lengths. So F to G, this little piece here is like the short piece. So what we can do to get the medium piece is multiply by 2. This has to be 18. So GC is 18 since it's the medium piece. Then FC is the whole thing, the long piece. So this is just 9 plus 18, or 27. So the medium piece for that one is 18. The long piece is 27. So remember, short, medium, and long. If they give you the short, double it to get the medium piece, and then add them together to get the whole thing, the long piece. Number 17, another centroid problem. They're given this a little bit of a trickier setup, so we're going to have to draw this one as well. We have triangle ABC. We have the centroid is G, and that's on median BE. So if I draw a line from B to E, somewhere on that line we have G. Okay, and that's what we have for that. Okay, so then good. Sorry, I didn't mean to scroll there. We know that BG is 4x minus 8. We know that GE is x plus 2. What they're asking us to find is the whole thing, BE. Okay, so this is a little bit tricky because we don't really know how long each piece is. They just gave us a kind of an equivalent expression with algebra. So we have to figure out how to make an equation out of this to solve for x. Well, here's the short piece. Here's the medium piece. We know that if we double the short piece, that equals the medium piece. So if I double this short piece, I can set that equal to the medium piece. So 2 times x plus 2, distributive property, I have 2x plus 4 equal to 4x minus 8. Add 8 to both sides and subtract 2x from both sides. It looks like x has to be 6. Okay, so that would be our first answer blank. But then they want BE, so what that means is I need to plug in BE is equal to BG plus GE. BG is 4 times, we said x was 6, minus 8, plus GE is x plus 2, but 6 is x. So on this left one, we have 24 minus 8, or 16, and we have 8 here. It's a good thing that the medium piece, 16, is twice as big as the short piece, which is 8, so BE has to be 24. That's a pretty tricky one, but you want to double that short piece to set it equal to the medium piece so that we could find x. So x is 6, BE is 24 for that one. Moving on, number 18, name a median in the triangle below. Again, this is vocab. Do you know what a median is? Medians are segments that go from a vertex to the midpoint of the opposite side. So PU is called an altitude. It's perpendicular to the opposite side, but not at the midpoint. RT, that goes through a vertex. That's an angle bisector because the angle is what's getting cut in half. So let's try this one. QS starts at a vertex, lands at S. S is clearly a midpoint, so QS is our answer. Medians go from a vertex to the midpoint of the opposite side. Here's another matching one. The one that looks like a perpendicular bisector is A here. All right, for this one, for when you do it, they might be all jumbled up, the pictures. A perpendicular bisector has to have a 90-degree angle, and the 90 has to be right by a midpoint or right on a midpoint. So it doesn't have to go through a vertex like an altitude does. So A for the first one. Then we have angle bisector. So look for where an angle is getting bisected, cut in half. That would be D for this one. Medians, like we just said, go from a vertex to the opposite side's midpoint. So that would be B, which means C has to be the altitude, goes from a vertex 90 degrees to the other side. Know your vocab, have pictures of all that stuff. Number 20, which of the following must be true? So what we know, there's not much work to show for this one. So what we know is we have two pairs of congruent sides, and then we have angles in between that are not the same. So what that means is this is Hinge theorem from 5-7. Since 100 is bigger than 80, 100 is across from a longer side than 80 is across from. So I know RT has to be longer than VX. That's option A. Okay, look at the other options. RT smaller than VX or RT equals VX. Those are going to be the only three options. So since 100 is bigger, the side across from 100 is bigger. Since 80 is smaller, the side across from 80 is smaller. This one says name the point of concurrency of the angle bisectors. Okay, well, here's an angle bisector. Okay, and here's an angle bisector. You can tell because in the corners, oops, well, it went away, but that's okay. In the corners, we have angles being cut in half. Okay, N is getting cut in half, and so is O. So if you trace those two lines, they run into each other at Z. Okay. Finding the orthocenter. So finding the orthocenter is actually pretty quick if it's a right triangle. It's a little bit more complicated if it's not. I'm going to do my lazy graph again, where this is at 3, and this is at 7, and this is at 6, just on the graphs. Okay, so something like that. Okay. With a right triangle like this, the sides are altitudes. When we're finding the orthocenter, we're finding where the altitudes run into each other. Well, this is an altitude right here. It goes through a vertex, and it's perpendicular to the opposite side. This one here goes through a vertex, and it's perpendicular to the opposite side. So what we have is right here, we have, oh, I forgot to mention this was 2 on the graph. Right here, we have where the red line and the green line run into each other. So that's the orthocenter right there. It's at 2, 3. For orthocenters on right triangles, the orthocenter is going to be right there in the triangle, right there in the corner, right by the right angle. Okay. 23 and 24 can be tricky, so pay good attention. 23, here's what we have. We have, and by the way, this would be reflexive property. So we have side angle side, which means we can use Hinge theorem. Since the thing with the x in it is across from 22, which is smaller than 23, I know this angle has to be smaller than 75. Since 22 is less than 23, since 22 is less than 23, x minus 13 has to be less than 75, which means x has to be less than 88 if you add 13 to both sides. What that means, that's going to go right here. I know that 88 is too big to be x, because if x was 88, then the angles would both equal 75, and it would be impossible for the third sides to not be equal. Okay, so I have this one filled. I know what x is smaller than. I still need what x has to be bigger than. Remember that all angles have to be bigger than 0. Can't have a negative or a 0 measurement for an angle. So when you add 13 to both sides, x has to be bigger than 13. So 13 is less than x, which is less than 88. We'll try that again. 24 is the opposite, where here we started with the thing with the x in it is less than something. I'll show you here in the next one how that can be different. So let's take a look. Number 24, last one. Find the range of possible values for x. Okay, here's the thing with the x in it. It's across from 50. Here's the other one across from 49. So 2x minus 16 is across from 50. Since 50 is bigger than 49, 2x minus 16 has to be bigger than 36. Add 16 to both sides and divide by 2. We find out that x has to be bigger than 26. That's what x is bigger than. Another way to write that is 26 is smaller than x. So that's actually this one. We found this one first. And how that changes things is now we need to know what x has to be smaller than. So this x, we want to know what's too big to be that x. Well, we know that angles in triangles have a total of 180. So in this situation, we write 2x minus 16 has to be less than 180 degrees. It can't be 180 because then it would be too big to be in a triangle. So we already know what x is bigger than. We need what x is smaller than. We know x is smaller than 180, or the angle is smaller than 180. So we add 16 to both sides and we divide by 2. 196 divided by 2 is 98. So we know that x has to be between 26 and 98. Feel free to rewatch those as you need. That's it for this video. Don't forget to ask your teachers which questions are still giving you trouble. Thanks for watching.